So weather extremes are basically when the events like heat or temperature or precipitation go beyond the expected normal average temperatures. So if you take a particular place and you have a range of temperatures, and some of the warmest temperatures are, let's say, in the 95th percentile of the distribution, then when you keep hitting those 95th percentile temperatures, you would call it extreme, especially when it lasts for a few days. Same with the rainfall. If you have average rainfall of 50 millimeters per day, then you get pouring rain of 150 millimeters per day, then obviously that's an extreme event. And heat waves have high mortality, of course, and extreme rain causes floods, and of course then leads to cholera and other things that we just looked at. But there is the other side. Extreme droughts happen as well, and even though droughts are typically thought of as evolving slowly, we now have what are called flash droughts, which have warm temperatures desiccating soils and creating droughts that not only persist with these kind of feedbacks but also can grow very rapidly. So going back in time, the mid-century blighted potatoes and bubonic plague from the 1800s. There is a Gaelic rhyme translated into English: potatoes in the morning, potatoes at noon, and if I rose in the night it would still be potatoes. Okay. The numbers: Irish famine killed 2 million who emigrated between 1845 and 1850. 8.2 million was the Irish population in 1841, and 6.6 in 1851. So you can see the huge change in the number of people who emigrated because of the massive famine. And the Irish famine story remains very famous, especially in terms of large-scale movement to the west in the US, and then there were a lot of other socio-cultural issues associated with them as well. One of the best sources for compiled data is Our World in Data, so I grabbed a few figures from there. Famine victims worldwide since the 1860s. So the excess mortality due to famines are shown here. So you take expected average number of deaths and you look for excess deaths, like we are doing with COVID. COVID mortality is to be estimated still, but typically you take expected average deaths with old age and other causes, and then you look for estimated excess in deaths and try to see if that's related to COVID. Okay, so 1860s, and you can see 1870s was a massive jump with 20 million more, and you had 1890s, other spike here in the 1920s. So you can see this was several big famines killing millions in India and China in the in the late 19th century. In the 1920s, millions die from famine in Soviet Union and China. Famines in the Soviet Union again here. Several large famines related to World War II. The Great Leap Forward famine of the 1958 to 1962 in China, where Mao is under Mao is the largest known famine there. Okay, and you have several smaller ones all the way into 2010 to 2016. So famines continue to happen, and we are not as resistant as we think because of all our great prowess in science and technology, right? This is the annual rate of people dying due to famine globally per decade, and again 1970s jumps out, and one can conclude that over time the number of people dying due to famine has dropped. The distribution still matters. Places like Ethiopia, Somalia, I don't want to name any particular countries, but there are still countries with no proper governance structure, no elected governments that can handle situations and so on. And international community often steps up to help through UNESCO, UN, and other agencies. But Is it good news that the number of deaths are dropping? Yes, but there are other issues that are related to climate change, climate injustice and inequities and so on and so forth. You can also look at famines by world region over the same period, and you can see here 1880s Brazil, Persia, which is now Iran, Turkey, Europe had several. Ireland here, starting with the potato famine that we talked about, 1 million deaths. Finland even, Russia, Germany, USSR, Netherlands, and Asia, of course, dominates, with India and China experiencing many famines, with deaths order 2 million, 11 million, 2.7 million, and here is China during 1850 to 1961, pretty massive 1.6 million deaths, here 2.4 million deaths. Okay, and Africa now remains somewhat of a poster child even into the into the 21st century, and there are many issues there in terms of resources exploitation by outsiders, management, governance, poverty, etc., conflicts, and so on. But you can see that we are still not completely out of it, and climate change is exacerbating many things. Famines are always associated with pestilence and plagues and so on. Here's the example going back to China, bubonic plague. So we are looking here again at 1840 to 1960, and you can see that there have been some massive human plague cases in thousands, and even the last one was in the 1940s into 50s. So the third pandemic annual incidence in China circa 1850 to 1950. And map of outbreak sites in annual rainfall zones. So there is a direct connection with climate and famines that we are talking about. Note the fivefold difference in rainfall between the northern and southern plague belts. So you can look at the numbers here. You get pretty low rainfall as you come this side, but here you have very high East Asian monsoon circulation and rainfall, and the plague straddles this interface of transition from high rainfall to low rainfall regions and into these mountainous and coastal regions. So it's a combination of temperature and rainfall. Okay, so these are the non-linear effect of climate on plague during the third pandemic in China. Okay, so of course the idea is to look for how extreme rainfall is changing the dynamic, because the impacts on crops and then the impacts on mice that carry the flea and human contacts, food insecurities, etc., begin to feed into that. So along the way, population is something that makes big news, but this is controversial in the sense that consumption and greenhouse gas emissions are typically related to the rich Western countries, and almost all, or at least 75% of the emissions have come from them. So population growth by itself is not necessarily directly responsible for climate change in that sense of consumption and greenhouse gas emissions. But looking at population growth rate by half decade shows that we have basically been heading downward. So time trend in the annual percentage growth rate of population, actual 1950 to 2010. So fertility rates are dropping. Biggest reason is the education of women, it turns out, and because of medicine and so on, lifespan has grown, infant mortality has dropped, so the number of kids born by families tends to drop when that happens. Okay, so I'll come back and conclude this chapter with another little podcast on infectious diseases. But you get the story that the theme running through is the same. Climate perturbations as a multiple stressor or a stress confounder acting on top of population changes, migrations, food production changes, crowding, and water quality, air quality, and so on. Okay.